All right, young learners of mathematics. We're going to be talking about multiplying rationals here. And before we do this, it's very important to remind you that you can never divide by 0. All right? So if you have a divided by b, we have to qualify that by saying that b can't be equal to 0. So let's suppose you have a divided by b plus 2. With this problem, the denominator still should not equal 0. So we're going to say b does not equal negative 2. Or we could say a divided by b plus 2 times b minus 1. Well, in this case, the entire denominator can't be equal to 0, but using the zero product property, b can't equal negative 2 or positive 1. So we're going to be using that later on, so I want you to take a look at this just to make sure that you're ready when it comes up later on. Alright, so we've got a problem here. X squared minus 9 over x squared minus 1. We're going to multiply that by x plus 1 over x minus 3. The first thing we need to do is factor. And we want a prime factorization just like when we're multiplying typical fractions. So the process is no different than multiplying regular fractions. I cannot stress that enough. The most difficult part of these problems is remembering how to factor. Alright? So we're going to take this and factor every part. I'm putting in green highlight the parts that are perfectly factored. So I'm just going to rewrite those on the far right side as x plus 1, x minus 3. Now we need to factor, let's see, the x squared minus 9. Now that x squared minus 9, I need to write that as two factors. And if you remember, this is a difference of two squares problem. So either you've got this memorized as x plus 3, x minus 3, or you think what two numbers will multiply to negative 9 and add to 0. Well, that would obviously be 3 and negative 3. So x plus 3, x minus 3. Similarly, we're going to take a look at x squared minus 1. This is also a difference of two squares. We have x minus 1, x plus 1. If you're having trouble factoring, that's not necessarily the focus of this video, so you need to go back and work on factoring before you can work on this skill. So, now we've factored, the next part is to restrict. It is critical that the denominator is never equal to 0. So we're going to look at the denominators and make sure that they are never equal to 0. There are three numbers that are going to result in a denominator of 0. X cannot be 1. That's from that first term. X cannot be negative 1, that is from x plus 1, and x cannot be 3 because of the third denominator, the third factor in the denominator. If you don't believe me, plug in 1 for x in this expression and see if your calculator likes it or not. All right. The last part is the fun part. Destroy. So I'm going to double check to make sure that everything can be written as factors. I have one item times another item times another item over another item times another item times another item. Doesn't matter that those items look kind of funny because there's subtraction in them. The relationship between each item is only multiplication and division. This allows me to use the idea that division and multiplication are mutually destructive. So, our x plus 1s will cancel. Our x minus 3's cancel. And our final answer is x plus 3 over x minus 1, except x cannot be 1, negative 1, or 3. But Mr. Wiedenhoff, negative 1 doesn't cause a denominator problem in the answer, nor does 3. All right, I feel your pain. I really do. But if you break math at any point in the problem, it breaks math for the whole problem. So what you have to do is look at every single step and make sure that you're catching parts of the denominator. So look up top. There is a part of this problem where x cannot be negative 1. And since there's one part that it can't be negative 1, it can never be negative 1 for this problem. All right, we're going to look at one more example. X squared minus 9 over x squared minus 1 divided by, let's see, what was the last problem? X minus 3, x plus 1 over x minus 3. So let's make it x minus 3 over x plus 1. This is going to be a slightly different approach, but not too much. So, just like dividing regular fractions with numbers, we are going to change this to multiplication. So the first fraction doesn't change, and that's times x plus 1 over x minus 3. And guess what? You already done this, right? Because division and multiplication are so closely related, the same techniques are used. So we got the answer of x plus 3 over x minus 1. But we had a domain restriction of x cannot be 3, 1, or negative 1. All right, really important. With division, there's one more denominator that is not taken into account. So look at that x plus 1. That tells us that x can't equal negative 1. So everywhere there's a denominator, you have to make sure it can never equal 0. Negative 1 plus 1 is 0. That's why it doesn't work. Now, this is probably a bad example because notice how negative 1 is already showing up in my restrictions. So just be aware that there may be a denominator you're missing. So check every line and make sure that you're not causing any domain problems. Alright, that's it for this video. Check into the next video for the practice problems.